have a diverse gene pool because you've got individuals and all over that circle there. But if you're outbreeding only, everybody's going to end up in the middle, and they're going to be the same because you're only selecting for homozygosity in that regard. Breed gene pool diversity requires distinct lines in order to create selective pressure. We want differences within breed diversity. We need differences between dogs. We don't want to make them all the same. Outbreeding plans are self-limiting because as you remove the genetic differences between individuals, it becomes increasingly harder to outbreed or find mates that are genetically unlike each other. So think about it. If the best breeding for my dog is the one that's the least related and I breed them together, well, those lines are now related. So in the next generation, I got to find someone that's not related to either of those two lines and breed to that one, and now that's related, okay? And now my next mate, I got to breed to someone that's not related to all three of those lines. But you're going to run out pretty quick of someone that's unrelated to you, if that's the goal of your breeding, is to breed to the most unrelated. And it isn't achieving quality or health. All it's achieving is heterozygosity. And they'll tell you, look at what we improved. Our average inbreeding our average homozygosity went from this number to that number. Isn't this great? But it's got nothing to do with health. None of the types of mating systems, inbreeding, line breeding, or outbreeding, changes the frequency of defective genes or their dissemination. Outbreeding just disseminates defective genes in the heterozygous state, which is exactly what you want to do with endangered species, okay? Because there is no selection going on. You just want to minimize the expression of deleterious recessive genes. But when we have selection, and we can select against deleterious genes, the type of mating you're doing has nothing to do with genetic diversity. It's who is used for breeding that determines your genetic diversity for the next generation. So if you've got if someone likes to line breed and breeds these two together, and someone likes to line breed over here and breeds these two together, well, if you breed this one to that one and this one to that one, you're now outbreeding. Have you changed the genes of the next generation? Have you improved the genes of the next generation? No, because you've got the same genes, but they're now heterozygous versus homozygous. But it's got nothing to do with making the dogs better. Outbreeding will not change the frequency of deleterious genes. For dispersed breed-related deleterious genes, outbreeding will not reduce the frequency of affected individual. For breed-related disease, those genes have been disseminated throughout the background of your gene pool if you have a breed-related disease, okay? So when we study genetically, when we research genetic diseases, what we find is a lot of times the first couple of affected individuals are fairly outbred, because you don't need line breeding in order to create affecteds, because those genes have been dispersed in the gene pool. So affected individuals are produced in a random fashion. That's what will happen without breeding. And if you want to understand how disease is transmitted and expresses itself without breeding, look at our cat populations, because 95% of cats in America and around the world are random bred cats, are alley cats. Only 5% are fancy or pedigreed cats, okay, as opposed to dogs where we have like a 50-50 in terms of purebred versus the others. But we see the same genetic diseases in our random bred cats every single day as a veterinarian. You see our inflammatory bladder disease and diabetes and allergies and all the cat genetic diseases we see, but they occur randomly. And that's what would occur with outbreeding programs. It doesn't change how often affecteds are produced. It's just they come up by surprise now because you're constantly mixing the genes, so you have no idea where they are and when they're going to pop up. Genetic diversity, just real quickly here, they're looking at the major histocompatibility complex, or the DLA, or the immunity genes, and they say, well, you need to have as many of those as possible, which is a nice theoretical thing. But the bottom line is that every single immune-mediated disease or autoimmune disease is caused by a specific gene or a specific group of genes. It has nothing to do with their homozygosity or heterozygosity, and it has nothing to do with how many different immune genes or DLA haplotypes occur in your breed. Whereas the diversity people say, well, if a breed has 8 MHC genes and your breed only has 3, that is very poor diversity. But if it's a healthy 3, it makes no difference, because it's got nothing to do with disease. Unless one of those three is a disease-related haplotype, in which case you've got disease, you need to select against that one haplotype or that one group of genes, not about their homozygosity, heterozygosity, or the number of them. So again, it's identifying tools that are available to us, things that can be identified, and using those as the goals of breeding. And that's what we're being told, is to use genetic diversity and inbreeding coefficients as goals instead of tools. If you have something and you want to keep it solidified, you want to line breed on it. If you don't have something and you want to bring it into your lines, you want to outbreed on it, okay, and bring something in that you don't have. You know, these are tools, and they change with each mating and with each generation, but you can't do the same thing every single time, or you're going to really start to mess things up. All breeds are inbred with many different parameters causing changes to their homozygosity and genetic diversity. None of the manipulations that are recommended have to do with the health of the breed or selection against disease liability genes. Okay, so my mantra is that genetic diversity is breeder diversity. It's everyone doing something a little different that allows us to have diversity. If everyone's breeding to a particular sire and you have a popular sire syndrome, we lose diversity. If everyone is outbreeding, we lose diversity. If people are, some people line breed on this, some people are line breed on that, some people want to outbreed, which is fine. You know, I'll stop for a second here, because people say to me, oh yeah, you're the guy that says everyone should inbreed. And I'm not saying that, because everyone inbreeding is not good either. All right? It's everyone doing something a little bit different. There's reasons to outbreed. There's reasons to line breed. But once someone tells you you must always outbreed or you must always line breed, that's the wrong thing, because you're using tools as goals. And that's what, you know, what I'm trying to impart here. It's the varied opinion of breeders as to what constitutes the ideal animal and their selection of breeding stock that maintains breed diversity. When breeds have issues with genetic disease, the only way to improve their gene pool is through genetic testing and selection against the specific diseases and their associated liability genes. This is my new mantra. Pre-breeding health screening should become as universal as equine pre-purchase exams. If any of you are horse people, you know you're not going to buy a horse without a veterinarian doing a pre-purchase exam, because otherwise there's no way that you know that you're going to be able to utilize that horse or ride that horse for, you know, for whatever the purpose is that you're purchasing it for. You know, it could have laminitis, it could have navicular disease, it could have any sorts of things. And so that is the paradigm, you know, of horse people, is that you get a pre-purchase exam. Well, the paradigm of dog breeding should be pre-breeding health screening, is evaluating the health of every prospective breeding dog. Because if you're not doing that evaluation, then as well as evaluating the qualities, the positives and the negatives for the quality traits that you're looking at, you know, you need to do that evaluation, otherwise you're breeding blindly. And that's what is important. So the last slide for this first half, breed maintenance requires avoiding the popular sire syndrome, utilizing quality dogs from the breadth of your population to expand the gene pool, monitoring genetic health issues through regular health surveys, doing genetic testing for breed-related disorders, participating in open health registries to manage genetic disorders, and constant selection for quality and for health. That is the only way that you're going to maintain the quality of your breed. Okay, so that is the end of the first half, and it's exactly 1:20, which is right on time for me. We started 15 minutes late. So we're going to take a 10-minute break until 3:45, and then we'll proceed with the rest of the talk. Does anyone have any questions right now, or do you want to just write them down and we'll hold them till the end? Okay, all right, we'll see you back in 10 minutes.